Okay, let's look at this question. They said a square is inscribed in a circle such that each corner touches the each corner touches the circle, right? So how do you graph this like this one here? You have a circle, right? You have a circle here, right? They said that a square is inscribed in the circle. Means this one should be of course the graph here is ugly, but we should know that this is a square. So this is the x, the size, this is the size, okay? They must be equal, that's a square. They said inscribe means what? The four corners right of the square right on the circle, right? Now there is another term sometimes you may face, it's called what? A square is circumscribed. If a square circumscribes a circle, that means you have a circle here like this, and then you go like this, like this. This is a case about a square circumscribed, okay? But here, of course, we're not talking about circumscribed. We're talking about inscribed, okay? I just let you know some term. So here, inscribed, okay? Now there's a find a function that gives the area of the square as the function of the radius of the circle, right? And simplify the function as much as possible and describe any symmetry in the function. Make certain to show all the steps you use to come up with the function, as well as describe your reasoning, okay? First thing first, they ask us to find out the area of the circle. Of course, from here we can see the area will be what? The function of the x, right? Because this is square, so the length times the width. So we know this is the function of the area. See that? Actually find this one, but here, this one is the area of the function is the size of the square. But be careful that they ask for what? They find the area of the square as the function of the radius. So that means we have to substitute the x with something r, radius, right? So our job here is this. We need to find the relationship between r and x, and then we substitute, change the x to the r, okay? We go this way. Since this is square, so this must be 90 degrees. And then we drew this one, okay? This one will be, we call it as diameter. But we know diameter equals what? 2 times of radius, right? Radius, r is the radius. So from here, we know since this side, they're equal, and this is 90 degrees. So this one belongs to what? 45, right triangle. If you have that, we know that the relationship between these two is what? The hypotenuse will be equal to square root 2 times the x. Get that? Right? Now, since we need to find the substitute the x, we need to isolate this one. So we divide it by root 2, divided by root 2. So we got this one cancel. We have x equals what? This. Now, since they ask to find the area of the function as the radius of the circle. So that means this x, we need to substitute by what? By the r, right? So we go that means this times AR now equals what? AR equals to x, right? X is what? 2r over square root 2. But you have what? Square there, No problem? And then next step is what? 2 squared is 4. And r squared is r squared over square root 2 squared will be the 2. That would be 2r squared. You see? Now we find the area of the circle, the area of the square equals what? Is the function of the r right now, right? So we find this. It's a find the function that gives the area of the circle as the function of the radius of the r, of the radius of the circle. They ask you to simplify the function as much as possible. So this one equals this one. That's simplified already, okay? And they ask you to describe any symmetry of the function. Symmetry, this function, we know that if you put what? Of course, negative r does not make sense. I know that, right? Because the radius must be positive. So if you want, look at the symmetries like this. A negative r equals AR, because r squared and negative r squared are the same. So this one, if you draw the graph like this, if this is r, this is the area of the r, probably go like this. But this does not make sense. You know why? Because the negative r does not make sense. We have to cancel that one. So I don't know why they ask you. So they said any symmetry, there is a symmetry. It's what? Y-axis symmetry. But it does not make sense because the r cannot be negative, okay? Make certain to show that all the steps to come with this function as well as describe your reasoning. Our reasoning is this. Basically, the steps is like we have a square, right? All the sides equal, make a right angle. So x here, and then the radius is r, so diameter is 2r. So from there, basically the area of the square will be just the length times the width as x squared, no problem. But since they ask for what? The function of the r of the circle. So we got to build up the relationship. Relationship use a 45, 45, 90 triangle. You can get a 2r equals square root 2x. Or if you couldn't remember the 45, 45, 90 triangle, you still can do this question. Why? We can use what? Pythagorean theorem. So we can go like this, 2r squared, the hypotenuse squared, equals x squared plus x squared. Get it? So 1x squared plus 1x squared will be 2x squared equals to 4r squared. Divided by 2, divided by 2. This is 2r squared equals to x squared. So x equals what? Square root 2 times the r. You see? We got the same thing. This one, right? This one same as this one. You know that? This two same. Because this one times by root 2 on both numerator and denominator, you simplify, you got the same thing. And then you plug in back to here, so you still get what? Area of the radius as a function, right? Equals to x squared. So you mean square root 2x parenthesis squared. So you can get what? 2x squared. Same as this one. 2r squared. This is r, maybe. So this is r. This is r. Same as this one. See that? Okay. So